Good morning, grade nines. So today is Wednesday, May 12th. So I'm gonna pull up your work package here. So first things first, you're gonna do your daily quiz, which is plotting points on the Cartesian plane. So just like the exercise yesterday of the dinosaur, you have to connect the points with lines to get a shape. So you would do this shape, connect all the points, and then so on and so forth. And it's all going to be on the same graph. So you can either do it on lined paper, white paper, you can do it on this website that we will be using all along, or if you have paper copies that were printed for you specifically, you can do it on your Cartesian plane that's given to you. And then there's a second one on scatter plots. So you have to tell me the independent and dependent variables. You have to draw the scatter plot and make sure that you label your graph appropriately to get all your points. You're going to describe the trend, describe the correlation, and describe the relationship. So exactly like we've been doing yesterday. And then finally, we've got our lesson on the line of best fit. So you do need a ruler for this, or a line if you're doing on a computer, the option of making a straight line. So the rules for drawing a line of best fit. So you use a ruler to draw a line through the data points. The line must follow the trend of the points. The line should go through as many points as possible. So you're not trying to connect every single point. You're just going to try to touch as many of them as possible. There should be the same number of points above and below the line. And the line should pass through points along the line, not just at the end. Okay. So I'm going to show you an example. So we're going to make a line that goes through as many points as possible. And it continues for the graph. And you want an equal amount of points on each side. So I think that our best line of fit for this guy is this. So it doesn't touch every single point, but it does kind of show the same numbers above it. So we've got 3 above here and 3 below. So I don't want you connecting all the points. What you're doing is you're making a line through the points to show the trend. And I just realized that I wrote trend wrong. Okay, so that is how you do a line of best fit, and you need it to keep going. You're not just going to stop at this last point here. You're going to keep going with the line. So I'm going to need to clear this off so I can keep going. So when we're making predictions, there's interpolation and extrapolation. So the first one, interpolation. So the way that I think of it is inter means inside. So within or inside. So within or inside the data. Okay. So that means that somewhere in those numbers, you can make an estimation, and it's usually on that line of best fit. Whereas extrapolation, so I'm thinking extra here, so it's more than what you're given, is you're making a prediction beyond our data. So that very last point on your graph or in your table of values, if it's beyond that, then that means it's extrapolate. Okay, so this is outside the data. So that often requires you to extend the line of best fit. So like I'd drawn, we had our last dot and the line kept going. So if you're trying to make an estimation about something at the very end, then that means that you're extrapolating. Okay, so we're going to look at some examples here. So how tall was Julie when she was 5 years old? So if I'm going to clear this, we look at our graph. Okay, so at 5 years old, she is about 110 centimeters, we'll say. Okay, I'm going to type that. And that was inside of our data. We didn't have to look past our line or anything. So that would be interpolation. Okay, this is going to follow me along, but I need to look at the graph again. So how tall will Julie be when she's 9 years old? So if we look at here at 9, there's no point there. There's no dot. So I'm going to go back to make our line of best fit. This is going to be quite a mess a little bit. Okay, so we had our line of best fit that kind of went along like this. Okay, so if we look at 9, here, we're going to go up. Okay, and it's about 150 or 145 centimeters where the line is. Now this is our very last point. So we had to go above and beyond to estimate. So that means that it's extrapolation. Okay, so we're gonna go back here. We're gonna type, so I said about 145, and because it's outside of what we know, it's extrapolation. Okay, we're gonna go back to our graph. So how old was Julie at 100 centimeters tall? So we're gonna put our line back where it was, similar to this. So 100, so she was 4 years old when she was 100 centimeters. And that's inside of our data, that's inside of what we know. So we're gonna go back, and I said she was 4, I believe. Yeah. Okay, so she is 4 years old, and that was inside of our data, so that was interpolation. Now, how tall was Julie when she was born? So we're gonna go back, and that's age 0. So that's gonna be our very first point here. So if we look at our line, so here it says at 0 years old, she was 60 centimeters. But that wasn't part of our data. So that's just part of our line. That's just an estimation because of our line. So that's going to be extrapolation. I said 60. Okay. Okay, so 60 centimeters, and that is extrapolation because it's outside of what we know for sure. Okay, so I'm going to clear this. And I'm going to look at the independent work real quick. Oh, no, we're not there yet. Okay. So just as a reminder, so a scatter plot shows a strong correlation when the pattern rises up to the right. A scatter plot shows a moderate pattern when it falls, and a weak correlation when there's no pattern that appears. Okay, so you should know this. This should be review for you. Okay, and recall again. So strong, the points nearly form a straight line. Moderate, the points are somewhat spread out but can still see a wide line. And weak, the points are dispersed more widely but still noticeable trend. So you've got practice questions that are here as well. Okay, so you've got quite a few practice questions, and I'm going to stop this so I can do the curve of best fit.